Now we're in section 2.2. 2.2, which is solving equations by multiplying, dividing. So now we're not just going to add, subtract to get x alone, but we're going to multiply and divide. So we're not going to go all the way through the section, but let's do as much as we can. So, okay. So it's the same game. We have the equal sign. That's the wall. X is saying I want to be alone. Now, the question is, how do we get x alone? Should I add 8 to both sides? No, because that's not really the opposite. At first, it might look like it is. You think, well, yeah, it is. Minus 8, opposite plus 8.
Yeah.
Well, the problem is the relationship. Yeah. So you want to, one of the things you want to do as you're moving higher in math is think not just about the symbols that are there, but about how they relate to one another, right? What's in the middle between them? It's a very relational subject, math is here. So what's in the middle? Nothing, which means times, doesn't it?
Yeah.
They're multiplied, aren't they? And we're always doing the opposite, right? So what's the opposite of multiplication? Divide. I got to divide, not add. Makes sense? Now, if that was, let me change it up, make sure this is really making sense for you. If that was minus 8 plus x, well then, yeah, I would add 8. Because then, it'd be adding, subtracting, and I would do the opposite number added or subtracted. That would be right. You see, because then it would have a different relationship. It's the same two people, but now they're added. And if I instead get rid of that plus sign and put the minus 8 right up against it, like that, right next to it, that's a different relationship, right? They're multiplying now. And so the opposite of multiplying is dividing, isn't it? So see, so always look at that relationship. So I'm going to divide. Now, when I divide, am I going to divide by the opposite, positive 8 or negative 8? It turns out you're going to do the same. Yeah, so this is a little different here. So when you, let me write a note for you. When you multiply, divide, use the same sign. You don't use the opposite sign like we did for adding, subtracting. Why not? Well, when we added and subtracted, we had to use the opposite sign to make it opposite. When we're dividing, it's the dividing that's doing the opposite. So I divide both sides by negative 8. What happens on the left side? What is negative 8 over negative 8? What's negative 8 divided by negative 8? It's just positive 1. This is just 1x or x. It's positive, isn't it? Because two negatives, adders, multiplied or divided. Two negatives divided being positive. And what's the other side? Two negatives? Positive 6. We're done. You don't need that 1 in front there. And we're done. Positive 6. Two negatives made positive. This good? All right, I'm going to go to bigger fish. Here's number 3. D is my variable. I'll just make it an x. Whatever. I'm always used to using x. All right, so x wants to be alone. What x always wants in equation solving. So x wants to be alone. What do we do? How y'all doing? You doing okay? My voice starting to fade into the Charlie Brown teacher. Wah, 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 wah. All right, after 2 hours of talking math straight at you, huh? All right, x wants to be alone. What do we do to get x alone?
We send that 120 divided into left side of the equation.
Well, yeah, we want to get rid of that 20. Tell me this. The 1 is nothing, right? 1, there's always 1s everywhere. We don't care about the 1. The 20 is the deal. Is that 20 in the numerator or the denominator? Denominator. So does that mean it's really multiplied or divided? It's divided. Do you know what times, Mr. Aaron? When you times by a fraction, you're really dividing. Right? If I say, 1/20th of the people were there. That's dividing by 20, isn't it? That's a small number. Multiplying by a fraction divides things, doesn't it? So that 20 is really divided. So what's the opposite of dividing by 20? Multiply by 20. I'm going to get rid of that by multiplying by 20. I'm going to go 20 on the right side and 20 on the left side. Is this making sense? Let me get rid of that number 3 there.
If the 1 wasn't a 1 and it was like a 3 or something, it would be different.
Yeah, we'll talk about that in a little bit. You're right. So is everybody good so far? Does everybody see what I'm doing? I'm trying to get rid of it now. A whole number, this 20 whole number. Anytime a whole number is interacting with a fraction, you can just get this x out of the way. It doesn't matter where. Just pretend the x is moved over here, and I'll just swap them. So I'm going to let these two interact. Whenever a whole number interacts with a fraction, what do you do with the whole number? Put it over 1, because whole numbers are really over 1. Are you aware of that? 20 is the same as 20 over 1. And so what happens? Cross cancel, huh? And so sure enough, that's just x. I mean 1 over 1 if you want. There's a 1 and 1, but that's just 1. That's just x. See how that got x alone? That got rid of the 20. 20 in a denominator, you multiply by whole number 20, because that's over 1 and cancels it. And whenever you do one side, you have no choice but to do the same thing to the other. Keep the balance. So now on the other side, same thing. Over 1 and what? Cross cancel again. Remember, you don't multiply. You only, if they were both in the top, if that 4 was in the top, I would multiply. If they're both in the top or both in the bottom, if they're both the same level, you multiply. But if one's top, one's bottom, you cancel. That's cross cancel. That's dividing. 4 goes into 20. Right? Bottom to top is dividing, isn't it? So that's going to divide. 4 goes into 20 5 times. Yeah, the 4 was on the bottom from the beginning. They gave it to me that way. 1/4. So what does that leave? 5. We're done. We got x alone. It's 5. So everybody see what happened there? So I just multiplied both sides by 20. 20 over 1 canceled this 20. On the other side, 20 over 1, the 4 canceled into it. To be 5. That got x alone. So remember, a fraction, anything in the bottom of a fraction, is really dividing. All right, let's try another one. What's first on this one to get x alone? Yeah, so here's x. He's got a 5 right next to him. And that 5 is multiplying him, right? That 5 is, consider the relationship. He's timesing the x. He's right next to it. And the 8 is subtracting. So, going to get rid of that 8 first. So how do you get rid of that minus 8? Plus 8. Right, we always do the opposite. And so that's 5x equals, what is that? 45. 45. And now, x wants to be alone. Now what do we do? So we do the adding, subtract. We didn't have any parentheses. We'll have that later. Add, subtract. We did our adding and subtracting. And now last step is always divide by the number next to x. Divide both sides by 5. Because that gets x alone, huh? And that'll be 9. That good? How we doing? Are we extremely happy about that one? So 3x minus 8 minus x. 3x minus 8 minus x plus 4 equals 0.
That's 2.2, right?
Yeah, we're still in 2-2. All right, let's try that one. So you know the deal. X and 1 be alone. So remember the steps. Clear your parentheses. We don't have any parentheses. I'll write it out anyway. Clear parentheses. Do your adding, subtracting. Divide by the number next to x. So there's the step. So step number 1, get rid of parentheses. We'll have those up later. Step 2, do your adding, subtracting. So do your adding, subtracting right there. So add and subtract what you can add and subtract. So this is 3x minus 1x, huh? That'd be 2x. Good right there? Does that make sense so far? Hey, here's a mistake I see sometimes. Tell me what's wrong with this. One thing sometimes I see is people go, oh yeah, I learned this, we got this, we got this. Got to do the opposite, plus 1x to both. That cancels 4x, and then bring down the other stuff. That's not right. What's wrong with that? That's almost like what we did before, but it's a little twist on it. Yeah, you're telling me what's right to do, and you're right, that's what's right to do. But I want to know why is this wrong? What's untrue about this? Good job. See, that thing where you do the opposite, that's when they're on opposite sides. If this minus 1x was over here, yeah, that'd be totally the right thing to do. Right? You only do the opposite when they're on opposite sides. These guys are on the very same side. So they just combine together. You can't add 1x twice on the left and nothing on the right. You didn't keep the balance. Right? Everybody see what's wrong about that? So watch out for that. So it's a mistake I see often. So instead, these guys are on the same side. They make 2x, don't they? And then minus 8 plus 4, what's that? Minus 4? Good to there. Now x wants to be alone. What are we going to do? Add the 4. Gonzo here. Right? Bring down the 2x. And so we did all of our adding, subtracting. Last step? Last step is always divide, right? Last step is divide. Boom. X is 2. How we doing? Is this good? Making sense? Questions? A couple more minutes. Can you guys take a couple more? Okay, this is going to be a little harder. Here's the wall. Y wants to be alone. All right, go ahead on that. This one's a little more tricky. Be careful on this one. Okay, so y wants to be alone. What's my first? Let me do this one with you. What's my first step here? Add the 10, huh? Gonzo. Good. So bring this down. Six. Good. 10 minus 4 is 6. Good so far. Now, we're going to have to do something a little different. What are we trying to do? We're trying to get y alone. Y won't be alone. It's always the deal. So trying to get y alone. What could we do? Yeah. To get rid of both of these at the same time. What will get rid of both of them? Do the upside down. Because remember, cross-canceling will take effect, and they'll both cancel out. Am I making any sense? Let's try it. So multiply this side and this side by the upside down. 7 over 6. And whatever you do to one side, same thing to the other. See what will happen? The 7s will cancel and the 6s will cancel. You tracking with me? Do you see what happened there? That puts y alone. Right? Because remember, there's cross-canceling. When you multiply fractions, when you times fractions, you're allowed to cross-cancel. And that gets y alone in just one step like that. So now, what happens on the other side? How do I carry out this side? What do you do? Good job. Yeah, anytime you have a whole number interacting with a fraction, put it over 1, make it look like a fraction, because that's what it really is. 6 over 1, and then what? Cross cancel again. Remember, whenever you're multiplying fractions, you diagonal. So what's left? 7 over 1, and that's just 7. We don't leave 1s in the bottom, right? Why not? Because 1 goes into 7 times. It's just 7, huh? 1s in the bottom are doing nothing. So we never type in an answer. Don't type in the Math Excel 7 over 1. It'll tell you it's unsimplified. So just 7 on that.
Could you
Question?
just multiply the 7?
In the beginning? Totally. Yeah, maybe I should show that way too. I debated which way to do it. Because later, we'll have to. 6 sevenths y minus 10. Yeah, you're totally right. 6 sevenths y minus 10 equals negative 4. Negative 4. Did I flash off that too quick? Are we okay there? Everybody good there? Yeah. Yeah, so your suggestion, Caitlin, right? That's a good suggestion. Another way you could do this problem is you could say, look, I'm going to get rid of that 7 by just multiplying through by 7. So, my little thing's not working right. There we go. 7 and 7, like that. Right, that's okay to do because I'm doing the same thing to the left and the right. All the terms on this is a second way to do this problem. And if you do that, then this is over 1, cross cancels, you get 6y minus 7 times 10, 70, minus, I'll just do this quick because it's just a second way. And then, to get y alone, you would add 70. Boom. 6y is, what is that, 42. Last step to get y alone, divide by 6, y is 7. Same answer. Isn't that beautiful? It always works as long as we follow logic. Hold on, we got 4 good minutes. You've paid for those minutes. I want to give you all your money's worth. And more, maybe. But no, I'll let you go on time. Let's do one more. We can squeeze in one more question. You ready? We'll end with this. A dog's weight is 30. That's a 30. Well, I need to write smaller. Let me try. A dog's weight is 30 pounds, LBS pounds, plus half its weight. If you can read my little scribbles there, I'm kind of running out of room. It's weight. That's weight over there. It's for sure 45. You're thinking it's for sure 45. We all speak the English language. Let's just carry the English right on through, right? Okay, let's say a dog's weight. We're saying 45. 45 is, I'm just going to pretend it's 45 and see if that works out. 45 is 30, right? Plus half its weight. What's half its weight?
You don't know the dog.
What's its weight again? What's its weight again? We said it's 45. So half that would be 22.5, wouldn't it? That ain't true. Not 45, is it? Everybody see that?
Yeah.
Doesn't work. 45 is not 30 plus half of 45.
Yeah.
Not true. It's easy to get confused with the 30 and half the 30 is 15, but it didn't say half the 30, it said half the dog's weight. Right?
Yeah.
So it ain't 45.
30 pounds.
I wouldn't give you one that simple, would I?
So it's 30 plus.
So what's the dog's weight?
X.
Dog's weight is X? Go to the doctor. How much is your dog weigh? X. Really?
No, but I said you put it at 30 pounds. 30.
I'm going to let you all